All right, ladies and gentlemen, here we're going to tackle the derivatives of our 6 trig functions. So you'll notice right away there's a lot of them and they're quite sort of random. For example, the derivative of sine is cosine, which is pretty simple, but the derivative of cosecant of x is negative cosecant of x, cotangent of x. So it's a lot to remember, and you do eventually have to have these memorized for the AP exam. However, I think the best way to memorize these is by using them. So for the first little while, I'm going to give these to you when you need them, and we'll worry about memorizing them a little bit later. As a reminder, since it's been a while since we've used one of these, what these functions model is anything cyclical. So remember, like the sine function, it has waves, right? So that's what the y values of our sine function looks like. And in this case, it models the height of the Ferris wheel at Navy Pier. You can imagine any Ferris wheel. So your height goes up to a certain point, comes back down to a minimum, goes up, comes back down. And if we're taking the derivative of this, this tells us in this context the speed at which we are spinning. Okay. This one obviously is a little bit more challenging of a derivative, so let's go back to the simple ones as a warm-up for this here. The way we use these rules is pretty easy, so we just look them up as we need them, right? So for example, my first function is y is cotangent of pi t. So I need the cotangent function, and I see that its derivative is cosecant squared. So that means that y prime, the derivative of y is going to be negative cosecant squared of pi t. And I'm going to put parentheses around everything that's inside of the cosecant, just like the cotangent here had parentheses in it. But I'm not quite done because I need to do chain rule. So the derivative of pi times t is pi. So make a note of this again, that we have to do chain rule anytime I have a function within a function. And we're going to make a note too that pi t, the derivative of that is pi. So we remember that pi is just a number and it works like any other number in this case. So that's my derivative of cotangent of pi t is negative cosecant squared of pi t times pi. I could even rewrite it like this if I wanted to, with the pi in front. Alright. Now we want f prime of pi over 3. So that's, again, just a number we're plugging in for x, given that my function f is x times sine of x. So here, notice we did not use product rule in the previous example, because cotangent is a function, it's not being multiplied by anything. But here, the x is being multiplied times sine of x, right? So I need to use product rule. So f prime of x, well, we'll do the first function times the derivative of the second function, so it's going to be f. And then I need my derivative of sine. So my derivative of sine is cosine of x. So x cosine of x plus, and then the derivative of x is 1, so 1 sine of x. Obviously I don't need to write that 1. So that's my derivative of f, and remember I wanted f prime of pi over 3. So I've plugged in pi over 3 for every x that I see. And remember to evaluate these. You could use a calculator, make sure you're on radians mode, or we're going to use our old friend the unit circle. And I gave you a unit circle in this handout. So the way this works, right, is that on my unit circle, cosine is my x value, sine is my y value, and then I find the particular value I'm trying to plug in. So here we're using pi over 3. So notice cosine of pi over 3 is 1/2, sine of pi over 3 is root 3 over 2. So I'm going to make those substitutions. So I have pi over 3 times cosine of pi over 3 is 1/2, plus sine of pi over 3, and one more time, sine of pi over 3 was the y value, root 3 over 2. Okay, so that is f prime of 3 in exact terms, right? And we could even rewrite that as pi over 6 if we wanted to. Okay, so we can we can say in exact terms is precise. If you punch this into your calculator, you would get a big long decimal, which is also f prime of pi over 3. It depends on how we're asking you to write your answer. Okay, let's tackle the application here. So we want the speed of our Ferris wheel, and our height of our Ferris wheel is given by f, and we want, again, the rate at which our height is changing. So again, that should cue you in. We want f prime of t equals 2, so f prime of 2. All right. So here we want to start by just taking the derivative of f prime, f prime. So f prime of t is going to be the 100 is just hanging out in front of the sign. And we already saw the derivative of sine is cosine, so we're going to use that one again. Cosine of pi over 4 t times the derivative of pi over 4t, which is pi over 4, plus the derivative of 100, which is 0. So we're done. Here's my derivative. I can simplify that a little bit. I'm going to say 100 pi over 4 cosine pi over 4 t is my derivative. And I just combine my two constants there. And then I'm plugging in 2. So I want f prime of 2. Which means I plug in 2 for t. And notice inside there I get cosine of pi over 2. So 2 over 4 simplifies to just a 2 on the bottom. And 100 pi over 4 is hanging out. And then I'm going to go back to my unit circle. So notice pi over 2, my cosine is 0, right? So what I get is 100 pi over 4 times 0, which is just 0. So that means my height is not changing at t equals 2 seconds. So I say 0 feet per, do I say feet? I didn't give you units, I should have. Let's say it's feet per minute. And what that means in context is this is a maximum or a minimum of my height. So if my height is going up and down in this kind of wave pattern, we just found that at 2, we have a horizontal tangent line, right? So we have either a maximum or a minimum. We don't know yet which, but we know we're at the very top or the very bottom of our Ferris wheel. Okay. So the most challenging part of this lesson for most students is that unit circle part. So make sure you have that on hand, and as you run into those problems, you're using the unit circle and then paying very close attention to how the examples are making those substitutions.